Cruise ships weigh over 100,000 tons, yet they float, complete with swimming pools, theaters, even roller coasters. If you drop a bowling ball in water, it sinks. But these floating cities, thousands of times heavier, just glide along the surface. It seems to defy physics. How can something so massive stay afloat? Today, we're not just accepting it, we're going to understand it. We'll uncover the ancient principles, clever designs, and hidden tech that keep these giants upright. By the end, you'll see cruise ships as one of humanity's greatest engineering feats. Why don't heavy things always sink? A log floats, a pebble sinks, yet the log is heavier. The secret is density. How much mass is packed into a given space? A pebble is dense, packed tight. A log is mostly air and wood, so it's less dense than water. If you're less dense than water, you float. More dense, you sink. But cruise ships are made of steel, far denser than water. So why don't they sink? The trick? A ship isn't a solid block of steel, it's mostly hollow, filled with air. Engineers use shape and air to make the ship's average density less than water. This brings us to displacement. When you put something in water, it pushes water aside. The amount of water displaced creates an upward force, the buoyant force. Gravity pulls the ship down. Buoyancy pushes it up. For a ship to float, the upward push must equal the ship's weight. So, how do you maximize that buoyant force? You can't change water or gravity, but you can change the ship's design. The ship's shape is the key. It's not just about floating, but floating stably and safely. The hull must displace enough water to support the ship's weight, without tipping over. This is where engineering meets physics. The ship's design is a masterclass in using density, displacement, and stability. But to really understand how it works, we need to meet the ancient Greek who first figured it out, in his bathtub. Archimedes' principle is the foundation of it all. It's the reason a steel ship floats while a steel wrench sinks. The ship's hollow shape and massive volume are what make the impossible possible. Next, let's see how Archimedes' discovery changed everything, and why every cruise ship owes its existence to a eureka moment over 2,000 years ago. Let's dive into the science that keeps these giants afloat. Ready for the real secret? Archimedes, the ancient Greek mathematician, had his eureka moment in a bathtub. He realized that the water he displaced was equal to the volume of his body. This led to the Archimedes Principle. The upward buoyant force on an object in water equals the weight of the water it displaces. So, if a ship weighs 100,000 tons, it must displace 100,000 tons of water to float. The ship sinks into the water until it reaches this balance. That's why the plimsoll line on a ship's hull marks the safe loading limit. Add more weight, the ship sinks lower, displacing more water, until it reaches equilibrium. The hull is designed to maximize displacement without sinking too deep. Archimedes gave us the why of floating, but the how is all about shape. A solid steel block would sink instantly, but a hollow, carefully shaped hull, that's the secret. Let's see why the shape of a ship is everything. Imagine two 1-pound pieces of steel, one a solid ball, the other a wide, hollow bowl. The ball sinks, the bowl floats. Same weight, same material, different shape. The bowl's shape increases its volume, displacing more water and creating more buoyant force. Cruise ships use this principle. Their hulls are giant hollow shells, mostly filled with air. This lowers the ship's average density below that of water. The wide, flat-bottomed hull spreads the ship's weight, displacing huge amounts of water with a shallow draft. This shape also provides stability, making it hard to tip over. The hull's design balances the center of gravity and center of buoyancy, so if the ship tilts, it rights itself. The wide base acts like laying a pencil on its side, stable and steady. The hull's shape does two jobs. It floats the ship and keeps it upright, but the ocean isn't always calm. For a ship carrying thousands, you need more than just a good hull. That's where high-tech stability systems come in. Next, let's look at the hidden technology that keeps these floating cities steady, even in rough seas. It's not just about floating, it's about comfort and safety. The hull is the foundation, but the tech is the secret weapon. Here's how it works. The hull gives passive stability, but cruise ships need active systems to stay level in rough seas. Enter ballast tanks and stabilizers. Ballast tanks are huge compartments low in the hull, filled or emptied with seawater to adjust the ship's balance. As fuel is used or cargo shifts, ballast water is moved to keep the ship stable. If wind or waves push the ship, water can be pumped to the opposite side to counteract the tilt. For quick corrections, ships use fin stabilizers. underwater wings controlled by computers. These fins adjust in real time using sensors to detect rolling and instantly push the ship back upright. The result, a smoother, safer ride, even in choppy water. Without stabilizers, even moderate waves would make for a rough, uncomfortable journey. Ballast tanks handle slow, big changes. Stabilizers handle fast, small ones. Together, they form a high-tech defense against the chaos of the sea. The combination of hull shape, ballast, and stabilizers keeps thousands of people safe and comfortable. It's ancient physics, modern engineering, and constant vigilance, all working together. That's how a floating city stays steady. But just how big are these cities? The numbers behind cruise ships are almost unbelievable. Let's look at the mind-blowing stats that make these ships true marvels. Prepare to be amazed. The largest cruise ships have a gross tonnage over 220,000, more than 100,000 tons of actual weight. That's like floating 16,000 elephants at once. These ships are longer than 4 jumbo jets end-to-end, over 1,100 feet. Stand one up, and it's nearly as tall as the Empire State Building. Each ship carries over 6,000 passengers and 2,000 crew, 8,000 people, plus all their luggage, food, and water. There's enough steel in one ship to build the Eiffel Tower several times. The engine rooms generate enough electricity to power a small town. Every ton added, people, supplies, fuel, means another ton of water must be displaced. When everyone boards, the ship sinks a bit lower, perfectly balanced by Archimedes' law. The scale is staggering, a moving city, the mass of a mountain gliding across the sea. Every detail, from hull thickness to stabilizer power, is calculated to handle these forces. Cruise ships aren't just big boats. They're among the largest, most complex moving objects ever built. But what if something goes wrong? What if the hull is breached? Let's see how modern ships are designed to survive disaster. Safety is built in at every level. Here's what happens if a cruise ship gets a hole, and why Titanic-style disasters are almost impossible today. The Titanic taught us hard lessons about ship safety. Modern cruise ships have watertight compartments, sealed sections that prevent flooding from spreading. Bulkheads now extend well above the waterline so water can't spill over like it did on the Titanic. Ships are built to stay afloat even if several compartments flood. Ballast systems can shift water to counteract listing. Stronger steel, seamless welding, and advanced navigation tech make accidents far less likely. If the worst happens, there are enough lifeboats for everyone. Fully enclosed, self-righting, and engine-powered. Evacuation drills and safety systems are constantly updated. No ship is truly unsinkable, but today's cruise ships are engineered to survive damage and protect everyone on board. The legacy of Titanic is a ship that's its own best lifeboat. Modern cruise ships are floating fortresses built to endure. Cruise ships don't float by magic, they're a triumph of science and engineering. Archimedes' Principle is the foundation. Float if you displace your own weight in water. Engineers shape steel into massive, hollow hulls, lowering average density and maximizing stability. Ballast tanks and stabilizers add high-tech control, keeping the ship level and comfortable. Watertight compartments and safety systems protect against disaster. Every cruise ship is a carefully balanced equation of forces. A moving city, perfectly poised between gravity and buoyancy. Next time you see one, remember, it's not just a big boat, but a masterpiece of human ingenuity. Cruise ships don't defy physics, they master it. Ancient principles, modern tech, and relentless safety working together. With enough cleverness, we can build what once seemed impossible. The invisible battle between gravity and the sea is won every day. It's not magic, it's science. And that's even more amazing. So there you have it. The secret to floating cities is ancient physics and modern engineering. A giant steel bowl, mostly air, displaces its own weight in water and stays afloat. Add stabilizers and ballast, and you've got a cruise ship. Understanding the science only adds to the wonder. Thanks for watching. If you enjoyed this, check out my video on how airplanes fly. If this blew your mind too, give it a like. And don't forget to subscribe for more stories that change the way you see the world.